Thank you, Todd. This is going to be a three-part talk. I will be spending a few minutes here giving the introduction, telling you what we really mean when we talk about bringing your own capacity, and then a little bit of context. Matt will have the middle part of the talk, talking about some work we've. Sorry about that. Is this better? Introduction and context. Then Matt will be talking a little bit of the talk about our initial experiments in terms of bringing capacity from HPC systems. And then at the end of the talk, I will be introducing and giving a very brief demo of our new tool to allow end users to do the same task. So bringing your own capacity, this isn't something that technology that we're promulgating. It's not something that we invented. It's our attempt to describe a trend that we see occurring among our users and in high throughput computing generally, where researchers increasingly want to use compute capacity to which they have access, but their system administrators do not. And that's very different than our current setup, or what we're used to in something like the Open Science Pool, where the Open Science Pool is this collaboration between. All right, if this mic is, sorry, a collaboration between pool administrators, right, and individual users, and their usage are tracked, but it's all based on groups. It's all based on inter administrator cooperation and collaboration. And the key part here is that these users, these researchers who have access to private resources, or resources that the system administrator, excuse me, the conduit administrators don't, want to do this work from their usual access points and for their usual jobs. And I think it's important to emphasize here that in addition to kind of the technical barriers to these users, these researchers making use of their own resources without an access point already set up for them, it's actually a really important usability barrier and an efficiency one as well, in terms of if they have an existing workflow they want to make use of additional resources for. And so that when we think about democratizing access to high throughput computing, usability is a really important thing to think about. So that's part of why we're working on this. A little context there. The first thing we did, I think without really realizing that this was the direction we were going in terms of making it possible for people to bring their own capacity, was this HPC Annex tool, which some of you may be familiar with. It's several years old, which is a self-service tool. Right, it requires a little bit of administrator setup to enable, but once that's all done, end users, right, the people who have their credit cards that they're willing to hand over to the cloud providers like Google, can use in order to burst into the cloud. Right, they have a deadline usually that they're worried about for the paper. They want to make sure their computation gets done. They're willing to pay to make that happen. But that's our baseline scenario there. In the second phase, which you heard about a little bit yesterday with the split starter and lumberjack talk from Maria, was focusing on HPC resources and being able to use these individual and researcher HPC allocations. Matt will very shortly be talking about our effort in a different aspect of that, where we did not, excuse me, Maria and Jamie were working on systems that did not have outbound networking from their execute nodes. That made it very difficult. We had to do this indirection through the file system. Matt was working on a somewhat simpler problem where the execute nodes did have access to outbound networking. And then the third phase that I'm going to talk about at the end of the talk is we're starting off with this HPC Annex tool. Matt?
Right, thank you. So yes, what I'm going to talk about is our initial experiments in bringing your own capacity, specifically to users of the Open Science Pool. I will start with a lightning overview of what the Open Science Pool is. Apologies for any oversimplification. So it's composed of federated compute resources from over 100 member sites. The federation part is important here. These are all individual sites with individual batch systems with, individual admins. They do their own thing, but they donate their spare resources from their own pools. And the two biggest pieces of software that are used to power this is Glide WMS, which submits pilot jobs to these sites batch systems. These are basically little execution points. They land as jobs on the site's batch system and then connect back up to the Open Science Pool, which is the one big pool that user jobs run from. And this is all triggered by user demand. So one of the components of Glide WMS monitors the demand monitors job pressure and launches pilots accordingly. And then the other big part is HT Condor CE, part of the HT Condor software suite, which is what handles the work of accepting the pilots and running them on the site's batch system. And so I'm going to talk about what we internally called XD submit. And this was mostly exploratory work. Speed was important and learning was important. The idea was to use the exact same infrastructure that we used for opportunistic sites to hook up HPC centers. And we had 2 users, between them access to 4 HPC centers. I am going to briefly list the steps needed for OSG path staff. The ones highlighted in blue are unique to HPC sites. So we need a user account for automated logins through HT Condor CE. One of the things we need for HPC sites is we need an exemption from 2-factor authentication, because we obviously can't do that automatically. The user has to add this account to their allocation so we can use their allocation. We need to set up HT Condor CE, and we need to add some configuration to Glide and WMS, basically so that the components listen for this project's jobs and only this project's jobs. And yeah, these are some of the considerations for allocation-based submission that did not exist in opportunistic, which is only the one project's jobs that own the allocation should result in pilot submission. And even then, only when the user wants them to. This is because it is the pilots that eat the allocation and not the payload jobs. And for this, OSG path staff need to keep track of the user allocations, and they also need to modify Glide and WMS config. We also need to make sure once the pilot has landed and joined the open science pool, that only jobs from that project land on that pilot. This just means we have to pass some information. On the flip side, we have to make sure that pilots are able to run jobs from that project as much as possible. Again, it is the pilots that eat SUs, and an idle pilot just wastes allocation. And therefore, the pilots need to be shaped specifically to the user's workflow, instead of being something that's general enough to be used for hundreds of people. And so there are a couple of drawbacks to this. One of them is poor user isolation. All of the jobs run under one Unix account, which is usually not a big deal unless you have a shared file system, which all HPC sites do. This gives the possibility of users accidentally clobbering each other's files or using a project quota. The bigger drawback is the amount of staff effort needed, the timeliness of staff effort needed. The user doesn't have any control of when pilots launched, how big the pilots are, how many pilots are sent. The user doesn't even have a panic button, except for removing all their jobs. And so they need to ask staff to do all this for them, which means that staff need to act quickly, monitor the situation in order to avoid wasting resources. And so this was, like I said, mostly a learning experience. We did actually help real users do real science. We gave about 1.5 million core hours for our chemistry user and our gravitational wave astronomy user. Cody Impact, who was talking yesterday about this, he got about 1/4 of his hours from his allocation that was used entirely through the system. But the biggest thing is how to run at all of these different HPC sites. Every HPC site is a unique and special snowflake, and they all have their idiosyncrasies, their environment variables, their queues, what SBatch parameters they accept. And we also had to develop a bit of tooling to work around site limitations that we were also able to use for opportunistic sites in the open science pool to give them additional features that we wouldn't have otherwise had. But the biggest lesson we learned is the need for a self-service model. Users need to be able to use their own identities to avoid causing issues for each other. And also, there's a lot of straightforward changes that should not require contacting staff. So I'm going to give the mic back to Todd.
Thank you, Matt. So as Matt told us, we had a set of problems dealing with or around the fact that this previous solution shared user accounts, in fact, or had a single shared user account effectively. And we did learn and had the ability to kind of get SSH into the system based with what we knew, and go ahead and spin up execution points using the HPC resources as our own accounts. And so we kind of wanted to combine these two aspects, right? We wanted to use what we learned about running pilots, but start them as the individual researcher. We can figure out how to automate this because we can do it from the command line without too much trouble. But as Matt pointed out, the big issue is two-factor authentication. How do we get around the security problem that we have, where we can't do anything on this on an automated basis because of the restrictions placed on logging in on the HPC systems? And when we phrased the question that way, the answer became obvious, right? We want to write a command line tool that gives us an opportunity to ask the user to log in on our behalf. So that's what we did. We call the tool HPCNX. I'll be getting the exact command line indications during the demo. But it has the following properties. I'm not going to talk very much about the implementation. We expect to be changing fairly rapidly over the next few months anyway. Pilots are user specific, and nothing between any set of pilots is shared, so that there's no possibility for any kind of bad overlap or misuse of resources. Once we've gotten the software developed, there will be no further staff involvement. Right? There's nothing that we have to do in order to allow users to make use of their resources. We give the user direct control over the use of the allocation and what shape the pilots have, and they can shut those pilots off remotely, again, without contacting us, without bothering the administrator of their access point. And we also threw in a little bonus there where the pilots will go ahead and automatically shut themselves off if they don't have any work to do, try and preserve as much of the allocation that we were given to use as possible. The downside of this approach, obviously, is that you do have to log in every time you want to do every time you want to add your own capacity again, right? You can't just let you log in once and store that kind of authentication forever. So I'm going to switch over to the demonstration right now. Hopefully everybody can see that okay. This is following, I should say that back, if you're following along in the slides, there's a link there to the provisional documentation that we have for OS pool users. I'm going to follow that recipe pretty much exactly here, at least as best I can according to my memory. We're going to go ahead and get started using the htconver command line tool that Todd was talking about yesterday, kind of our new approach, this now verb approach. We want to get started by submitting a job for this example. So we're going to say htconver, we're going to talk about a job, we're going to submit. It's going to be the example submit file that I have here. And the key thing for making this work on the annex, we just say, I want it to work on the example annex. This example annex doesn't exist yet, that's fine. As we say here, this job, we'll submit it. It's only going to run on the annex. It'll wait in the queue until you make the annex. Go ahead and make the annex for it. So next step, of course, is to create that annex, which should also be a very simple command line. Again, HPC Annex is implemented in the htconver tool. We have a noun annex. The verb we want to do is create. We're going to create the example annex. We're going to create it on the compute queue at expanse. And we need to say which project we're going to use from expanse. Give me a second here to pull that in from over here. Nope, not that one. Sorry, there we go. This is the part where we go ahead and do the two-factor authentication. I'm going to go ahead and log in with my password here. And it's going to ask me to do two-factor authentication. Hopefully my cell phone will get as good a signals right now as it did this morning. There we go. Okay. We printed out the things that we were saying in the slightly brighter, bolder color so that you would know that it was us and not the login system. So this was all the login system, the shared login, single sign-on, excuse me, that Exceed offers. That's how we access all the different systems that we do offer access to. We say thank you in bold to let you know that everything has gone okay. And then we start talking about what's going on. And there we go. This is a little ugly right now. We're working on making it a little bit prettier. Goal here is to let you know, in fact, something is happening. We're working on making progress. I don't actually remember what step 4 is anymore. Hopefully this will be done in a few seconds. But while it's working, we'll go ahead and switch back. Talk a little bit about the status. I forgot to say, I should have mentioned, that was actually just the OSG Connect, one of the OSG Connect login points. This has been successfully deployed to the HPC Annex tool out there. And as we'll see shortly, it is currently working. We support 4 different HPC systems right now: Stampede 2, Bridges 2, Expanse, which is the one I'm using right now, and Anvil. The downside of what I just said, that what we're a little bit unhappy about, is this was a deployment. We did have to do some work with the administrator in order to enable this tool. And we're working on making improvements, reducing the amount of administrative effort so that, you know, our ideal is that you download a new version of Condor, you install it, and maybe you turn one knob that says, yes, it's okay to let people bring their own resources, bring their own capacity. And then that's all that you as the administrator have to do. The other limitation I want to just mention briefly here is that right now the tool is targeting a single use case. We're trying to get this run a job or submit a job, start the annex, have your job run on it. This particular use case is very, very smooth. I want to make that very easy and very good for all of our our users before we try and work on anything else. That, of course, is the use case that I'm trying to demo here. And I have no, I guess it finished. I don't know what happened to the output here. Oh, there we go. May take some time for Expanse to establish that annex. One of the things that we like about the HD Condor tool is that we can be a little more chatty because nobody's trying to parse the output. Oops. And so one of the things we can do is say, this is what you might want to do next. And so we'll go ahead and take the suggestion from the HPCNX create tool and take a look at the status of the annex. I have no idea. Let's try that again. Okay. The annex is not established, which means we submitted the request for the lease. An annex is a named group of resources leased for the purpose of running Condor jobs. We asked for 2 machines. That's the default. You can change it on the command line. I did because that's a little more complicated. And then it also tells you a little bit about how your jobs are doing, right? There's 1 job in the queue right now for this annex that where we need to get established, and it's not currently running. There we go. Waited long enough. The job went through the Slurm queue out at Expanse. It is now running. You can see it's brand new. It's going to retire in about an hour. That's the default. Good for testing. Again, something you can change on the command line if you have reason to do so. By default, we request 2 machines. Again, that's for testing purposes to make sure that nothing you're doing accidentally depends on your jobs running on the same machine. We got a shed load of CPUs in those 2 machines. Job hasn't quite started running yet, so let's take a look at the job. Sorry, I'm gonna have to scroll back up here and find the job ID, which we printed out right there. Oh, and it actually got started while I was working on it. If you're curious and need to know, you can also find out exactly where it's running. This should hopefully be something you only ever need to know if you're having a problem. You can go to the administrator and say, yeah, I had a problem running it on this specific node, if that ends up mattering. So this job actually is just a quick little sleep job. Hopefully a number of you in the wow, I have no idea what's wrong with the screen here. A number of you in the audience will not be able to see the first line. That's a little unfortunate. Of the submit file, some of you will recognize it and gaze in awe on its beauty and simplicity. For the rest of you, I want to make 2 points here. This is completely unmodified. This job will run pretty much anywhere on any reasonably modern Condor. Nothing in it is specific to the annex. All of the annex specific stuff was done on the command line. This makes it very easy for you to test your jobs and run them on other resources, and then later on say, okay, now I really want to go ahead and do this for real on my allocation. Second thing I wanted to point out, this is a container universe job, which means it has a container image. This particular one is very small. I did that for make the demo go a little bit faster. However, the HPC Annex software recognizes this when you create the annex, goes and looks at the queue for the jobs that are supposed to be running on it, and downloads it during the creation phase of the annex. At no point during the running of the job is it ever going to download this file again. So that's really nice. Less so in the testing, but if you're trying to run 1,000 different copies of the job with all with the same container image, now you have a much smaller problem regarding external networking and storage space on the HPC system. I've talked for a while here. We can see that the job is still running. It's going to sleep for about 20 minutes. Some of you may have noticed that when you were looking at that example file. That's way longer, more time than I have. So we're going to go ahead and hit that panic button and make everything stop now. So it's an annex that we're talking about. The verb is shut down, and we need to tell you which example it is, or sorry, which annex it is. So it takes a little while to contact each of them. It tells them to shut down. We should see those results almost immediately. Let's go back up and take a look at the annex status here. It is no longer established. It is shut down. None of those will be using any resources out at the HPC site any longer. In the future, so I thought that actually went pretty well. Everything worked, which is astonishing as always for a live demo. We really want to be able to support additional use cases. Everybody loves DAGman, so that's obviously a big one for us to work on. The one that we're thinking about a little bit more carefully, right? A lot of researchers are not researching by themselves alone in the garage. They have coworkers, they have grad students, they have postdocs, who they might want to be able to use that allocation that researcher has access to. So we want to think really hard about what the model is for sharing those allocations in case people need to do that. As I mentioned earlier, the other big thing we want to do is eliminate this initial setup from the administrator, this external infrastructure that need to be set up in order to make that tool work. And Maroon talked about earlier, if you were here, this idea that we're moving towards a future where you can kind of pop off the access point away from the pool, that a pool is really just a central manager of a bunch of EPs. And in that universe, I'm thinking, when we've got to this point where you don't have to do anything in order to get this ability to bring your own capacity to work, we want to think about what it means in terms of democratizing access. Can we just have a little service where you hit a button on a website that gives you an access point? And there's no pool associated with it, but you don't need one, right? You go into you log into that access point we just created for you, you set up your jobs, you run a tool like HPCNX or some other tool very much like it, perhaps to access a path allocation. And there you have your pool, and there's no staff involvement, there's no administrative time. This is all end user stuff that we don't have to involve ourselves with, so it should scale very well. I'd like to thank you all for your time and the NSF for its money.